Okay, here's a Solomon question on the vector equations of lines. So relative to fixed origin, there are two lines, and there's one equation and there's the other, where s and t are parameters. Okay, show that the two lines intersect, find the position vector where they meet, and then find in degrees to 1 dp the angle between the lines. Okay, so to start with, the first thing is, when we're trying to show that find where lines intersect, it's neater to write these as column vector equations. So R, which I might call line 1, R I could write as how many i's? It's no I plus 7j take away 4k plus s lots of 4i subtract 3j and 1k. And it's easier to write this as a combined vector, which would be 4s, 7 subtract 3s, and negative 4 plus s. Okay? And with regards to line 2, r was going to be equal to the point on the line negative 7, 1, and 8, plus t lots of, well, how many i's? Negative 3, how many j's? No j's, and how many k's? 2 k's. And combining these together, I would get negative 7 subtract 3t, I would get 1, and I would get 8 plus 2t. So that's always my first starting point to write them as this. Now, show that the lines intersect and find the position vector where they meet. Let's make these two vectors equal to each other. Let's say that 4s, 7 subtract 3s, negative 4 plus s, must therefore equal to negative 7 subtract 3t, 1, and 8 plus 2t. Okay? Now, we can get three equations from these, and the three equations will be the following. We would get that 4s must therefore be equal to negative 7 subtract 3t. We would get that 7 subtract 3s must equal 1, and we would get that negative 4 plus s must equal 8 plus 2t. Now here's equation 1, we'll call it, equation 2, equation 3. Now before you launch into just solving them, one of these equations is easy, and just identify this, make your life a whole lot easier. That equation can give you s in a flash. From that equation you can determine, okay, by subtracting 1 off both sides and dividing by 3, that s must be equal to 2. Okay, so if s is equal to 2, in equation 1, what must t be? Well, t would be 4 times 2 would be 8, would equal negative 7 subtract 3t, and adding 7 to both sides and dividing by negative 3, we would get that t is equal to negative 5 there. Okay, and then let's check 3 works. So we know that works, Let's check 3 works. Negative 4 plus 2, that's equal to negative 2. I'm doing this side, and then checking that 8 plus 2 times negative 5, well, that's also negative 2. So we have found that s is 2 and t equals negative 5 are the parameter solutions, and therefore the coordinates of intersection are when I make s equals 2 here and t is negative 5 here. You should put them both in to check that you got the same answer, to check you know you did it right, but the answer would be 8, 7, take away 6 would be 1, and negative 4 plus 2 would be negative 2. To write it as coordinates, I should really write it as follows, and I'm done for the first part. Okay, so we've done the first part, and then we have to find the angle, the acute angle between the lines. Well, actually, I can rub all this out. I can go on to the next bit. To find the acute angle between two vector equations of lines, so say these are the two lines, and that's L1 and that's L2, and I know that vector equation of the line is 0, 7, negative 4 plus s lots of 4, negative 3, 1, and I know this equation of the line is negative 718 plus t lots of negative 302. If I want to find the angle between these two lines, and I know the intercept from part A, all I need is the direction components. That and that. That's all I care about for this. So I just need to know that the direction of line 1 is 4, negative 3 and 1, and the direction of line 2 is negative 3, 0, 2. I'm going to call that my A and call that my B, and I'm going to use the formula that cos of theta is A dot B over the modulus of A multiplied by the modulus of B. Careful here not to use the positions. We care just about directions. Okay, so let's work this out. A dot B is going to be equal to 4, negative 3, 1. 4, negative 3, 1 dotted with negative 3, 0 and 2, which will give you 4 multiplied by negative 3 plus negative 3 multiplied by 0 plus 1 multiplied by 2. And if you do that, you're going to get yourself negative 10. And let's work out the modulus of A. The modulus of A is the square root of 4 squared plus negative 3 squared plus 1 squared. And if you work that out, that's going to be equal to the square root of 26. And the modulus of B is going to be the square root of negative 3 squared plus 0 squared plus 2 squared, which is going to be equal to the square root of 13. Now we have everything we need. So cos theta is A dot B, which is negative 10, over this times this, root 26, root 13. Type that in your calculator and apply the inverse cos. Theta is therefore the inverse cos of negative 10 over root 26, root 13. So tap that in, making sure your calculator is in degrees mode because it asks for it. So inverse cos of negative 10 over root 26 multiplied by root 13, and you get yourself that theta is equal to 122.95, but just be careful, the question asks for the acute angle between them. Okay, so we found that that angle there is 122.95, so the acute one must be 180, take away that. So the acute angle is therefore 180 subtract 122.95, and when you do that, you get yourself 57.0 degrees to 1 decimal place. And we're done for that question.